In this video, we're going to be going over how to solve rational equations. All of the rules that you used when you solved regular linear equations are still going to apply. We just have to make sure that we are thinking about the fact that we have fractions, so we have some other rules that also need to be followed in order to solve these equations. Solving rational equations, this is probably going to be the most challenging thing that you do in this unit. Simply because there is not one set way that I can tell you to follow every single time. You have quite a few different options in every problem, and so the way you work one problem out might be different than the way somebody sitting next to you works it out. So I'm going to present this in a way that shows you 3 of the most common approaches, and just be aware that there are other ways that you can solve this. So if you think you are doing something correctly and you're still getting the right answer, just let me know, and more than likely you are just using another equally valid approach to solving these problems. So let's take a look at this first example. We have an m plus 5 over a 2m equals a 1 over m plus a 4 over 3. Our first option is going to be to go ahead and combine our fractions on the right here. We can go ahead and combine those into one fraction. So in order to combine fractions, we need a common denominator. We did that in previous lessons. So our common denominator in this case is going to be a 3m. So I'd need to multiply that first fraction top and bottom by 3, and the second fraction top and bottom by m. I have not touched the fraction on the left, so I'm just going to copy it down. And now I have a 3 over 3m plus a 4m over 3m. I now have a common denominator, so again, leave the fraction on the left. We have not worked with him yet. So now we have the ability to combine those into one fraction with a common denominator of 3 over m. We are going to take all of this numerator and add it to all of this numerator. So we have a 3 plus a 4m. At this point, we now have a fraction equal to another fraction. So this is essentially proportions. How did we solve proportions when we worked with fractions before? This is where we can go ahead and cross multiply. So here I'm going to take this diagonal and multiply them together. So I have a 3m times an m plus 5. And then I'm going to take this diagonal. So I have a 2m times a 3 plus 4m. Now it becomes a matter of just solving. So I have parentheses, so I need to go ahead and distribute to get rid of them. So here on the left, I have a 3m squared plus a 15m. And on the right, I have a 6m plus an 8m squared. Now I can go ahead and combine like terms. So here I can subtract the 3m squared to the other side. That leaves me with a 15m is equal to a 6m plus 5m squared. Now I can go ahead and subtract that 15m to make this equal 0. So I have 0 is equal to a negative 9m plus 5m squared. So let's move to the next slide so we have some more room here. So we are looking at a 0 equals a negative m plus 5m squared. Now we can go ahead and factor on the right so that we can start solving this for m. On the right, we can factor out a m. That leaves me with a negative 9 plus 5m. Now we have two things being multiplied together to equal 0. So that's our zero product property. So we can set both of them equal to 0. So m equals 0 or we have negative 9 plus 5m equals 0. On the left, we have m equals 0. That's already solved, so we just have to solve the equation on the right. So to get the m by itself, we're going to add 9 to both sides. That's going to leave us with a 5m is equal to 9. And we get m by itself by dividing by the 5. So 5 divided by 5 cancels out, divides to equal 1, so we have an m is equal to 9/5. So we solved this rational equation and we came up with two answers. We are not done at this point. Since this is a rational or a fraction, we still have to check for excluded values. So we need to make sure that none of the solutions we got are going to blow up our problem. So again, let's move to another slide to make more space. So these were our two potential solutions. Now we need to go back to our original equation, which was an m plus 5 over a 2m is equal to a 1 over m plus a 4/3. And we need to set all of our original denominators equal to 0 to find our excluded values. So our excluded values, we have that 2m is equal to 0, m is equal to 0, and a 3 being equal to 0 doesn't make sense. So these are my only two excluded values. I have m equals 0 as an excluded value, and on the left we need to solve for m, so divide both sides by 2, and again we get the same excluded value we already had of m equals 0. So we need to take a look at our final answers that we found, and we found that m was equal to 0 and m equals 9/5. Our excluded value tells us m cannot equal 0, so we're going to cross that out. It is no longer a viable solution, so our final answer then is only what was left of that m equals 9/5. That is the final answer to this rational equation. As I said at the beginning, there are multiple ways to go about solving these. So let's go back to our original equation and look at a second option that is equally valid as to how to approach solving this problem. Before, in the first option, we combined the 1 over m with the 4/3 to make one fraction. Another approach that we can take is to go ahead and subtract our fraction over. Let me get the right color here. Subtract this fraction to the other side so that it equals 0. So if we do that, we're going to subtract the m plus 5 over 2m from both sides. So here on the left, they're going to cancel out to equal 0. So now we have 0 is equal to a 1 over m plus a 4 over 3 minus an m plus 5 over 2m. Now we need to go ahead and combine all three of those fractions into one fraction. So again, we need to find our common denominator. So common denominator among all three of these is going to be 6m. So I would need to multiply this first one top and bottom by 6, the second one top and bottom by 2m, and this third one top and bottom by 3. On the left part of the equal sign, we still have a 0. Now we have a 6 over 6m plus an 8m over 6m, and then minus a 3 times the m plus 5, all over 6m. Now we have a common denominator among all three of these, so it's going to go ahead and stay, and we're going to end up with one fraction. We are then going to take all of this numerator plus all of this numerator minus all of this numerator. So we have a 6 plus an 8m minus the 3 times the m plus 5. Okay, so now we need to go ahead and distribute that 3. We need to distribute that negative 3 to get rid of the parentheses. So now we are looking at a 0 is equal to a 6 plus an 8m minus a 3m minus a 15. And all of that is over our common denominator of 6m. Now in the numerator, we need to go ahead and combine like terms. So here I have an 8m minus a 3m. That's going to give me a 5m. And here I have a positive 6 minus a 15. That's going to give me a negative 9. And all of that is over our common denominator of 6m. So now we have a fraction that equals 0. The only way a fraction is going to equal 0 is if the numerator equals 0. So we are going to set our numerator, the 5m minus 9, equal to 0. And then we're going to solve from there. So to get m by itself, add 9 to both sides. That leaves you with a 5m is equal to 9. And get m by itself by dividing by both sides by 5, arriving at your answer of m is equal to 9/5, which is what we got before. Now we still would have to check excluded values. Since this is the second time we're working this problem, we already did our excluded values and we found that m cannot equal 0. That was not one of the solutions that we got working this problem out this method, so we know our final answer is just the m equals 9/5. And once again, at the beginning of this video, I said I was going to go over the 3 most common approaches to solving these rational equations. So let's look at this problem one more time. And in this method, our third option, we're going to get a common denominator everywhere. So we've already found our common denominator to be a 6m. Now if you're working a new problem, obviously it's not going to probably be 6m. You're going to have to do the calculations to find what your common denominator is. But in this case, it's going to be 6m. So this guy I need to multiply top and bottom by 3. This one I need to multiply top and bottom by 6. And this one I need to multiply top and bottom by 2m. This is very similar to our second option. So now I'm looking at a 3 times an m plus 5 over a 6m is equal to a 6 over 6m plus a 4 times the 2m gives us an 8m over our 6m. Now from here we have a common denominator all the way across. So the only way this works is if we look at the numerators. So all that matters at this point is just the numerators. The denominator's all the same, so we can make this an equation without the fractions simply by taking the numerators. The 3 times the m plus 5 is equal to 6 plus 8m, and solve from here. So to solve, first I'm going to go ahead and distribute to get rid of the parentheses. That gives me a 3m plus 15 is equal to a 6 plus an 8m. Now I want to again combine like terms. So I'm going to go ahead and subtract the 3m to both sides, leaving me with a 15 is equal to 6 plus 5m. Then I'm going to subtract the 6 to both sides. That's going to leave me with a 9 is equal to 5m. Again, I'm still trying to get m by itself, so I'm going to divide both sides by 5. 5 divided by 5 cancels out, divides to equal 1, that's why it cancels, so we get a 9 over 5 is equal to m. And once again, you would need to check for excluded values at this point. Since we've already done that, we know our excluded value is that m cannot equal 0. That is not one of the answers we got with this method either, so our final answer is right here. Okay, now that we've gone over all three methods, let's go ahead and look at another example. So here in this equation, we have something that looks a little bit more complicated. There's more involved in our denominator here. We now have a trinomial, but the process is still going to be the same. So in our first option, we went ahead and we combined our two fractions on one side into one. So we want to combine these into one fraction. In order to combine fractions with subtraction, we need a common denominator. Well, in our case, we already have a common denominator, and that happens to be the 2b squared plus the 5b minus the 12. So in order to combine two fractions that have a common denominator with subtraction, we're going to take this numerator and subtract all of that numerator. So we have a 1 minus the 4b minus 1. And those parentheses are important because you will have to distribute that negative to both pieces. Is equal to 1 over ab plus 4. So let's go ahead and distribute that negative. That is essentially a negative 1. So we're now looking at a 1 minus a 4b plus a 1 all over our 2b squared plus the 5b minus 12 is equal to 1 over b plus 4. Now again, we can combine like terms. So here I have a 1 and another plus 1, so I can combine those together to end up at a negative 4b plus 2. And all of that was over our common denominator of the 2b squared plus 5b minus 12, and we still had the equals 1 over b plus 4. Now we have a fraction equal to a fraction, so one of the options we have is to use cross multiplication. So I can take these two, so I have a negative 4b plus 2 times that b plus 4, and that is going to be equal to the cross multiplication from the other angle. This guy, we have a 2b squared plus a 5b minus a 12 times a 1. So here on the left, this is FOIL or double distribution, however you remember it being called. So you're going to take that negative 4 times the b, so we get a negative 4b squared, a negative 16b, a plus 2b, and a plus 8. This combines for our negative 4b squared minus 14b plus 8 is equal to, on this side we have what's in parentheses times 1. Anything times 1 is itself, so we just have that 2b squared plus 5b minus 12. Now we can go ahead and combine like terms. So add 4b squared to both sides. Negative 4b plus, or 4b squared plus a 4b squared equals 0, so cancels out, leaving us with a negative 14b plus 8 is equal to a 6b squared plus 5b minus 12. Now we're going to add 14b to both sides. So negative 14b plus 14b equals 0, so that cancels out, leaving us on the left with an 8 equals, and then on the right we have a 6b squared plus the 19b and minus, where were we at? Let me flip back over, minus the 12. So now from here, we can go ahead and subtract the 8 to both sides. 8 minus 8 gives us 0. So we have 0 is equal to 6b squared plus 19b and minus 20. From here, we need to factor. So when we factor this is our a times c method. So we take the 6 times the negative 20. Which is going to give us a negative 120. From there, we list our factors of negative 120, and we are looking for the factors that not only multiply together to give us a negative 120, but combine together to add together to give us that positive 19. So just start listing your factors. You have 1 and negative 120, negative 1 and positive 120, 2 and negative 60, negative 2 and positive 60. There's 3 and negative 40, negative 3 and positive 40. Still, we're not adding to 19 yet. There's 4 and negative 30, and negative 4 and positive 30. And then there is 5 and negative 24, and negative 5 and positive 24. And now we have the factors that add to give us the 19. So we want to use that negative 5 and that 24. So we rewrite the middle term. So we still have our 0 equals a 6b squared. And instead of a 19b, we're going to rewrite that as a plus 24b minus 5b minus the 20. Now we can factor by grouping. So here we look to see what we can factor out. We still have our 0 equals. We can factor out a 6 and a b, and that's going to leave us with a b plus 4. And in the second set, we can factor out a negative 5, which is going to leave us with a b plus 4. And here, these two things should be the same. They are, so we factor those out. We have a b plus 4, and we have a 6b minus 5. So now we have two things multiplied together to equal 0. Again, that's our 0 product property. So we have a b plus 4 is equal to 0, or we have a 6b minus 5 is equal to 0. Here on the left, we get b by itself by subtracting 4. So we get a b is equal to negative 4. On the right, we add 5 to both sides, which leaves us with a 6b is equal to 5. And to get b by itself, we now have to divide both sides by 6, leaving us with a b is equal to 5/6. So we have our two possible solutions here. Now we just have to check for excluded values. So to check for excluded values, we go back to our original problem, which was this right here, and we look only at the denominators. And we want to set all of those denominators equal to 0 so that we can find the values that will blow this problem up. If you notice, these two are the same, so I only have to do that one once. So I'm going to set a 2b squared plus 5b minus 12 equal to 0, and I'm going to set a b plus 4 equal to 0. The one on the right's the fastest to solve, so let's go ahead and solve that one. We get b by itself by subtracting 4, and we get one of our excluded values is b is equal to negative 4. Now we go to the trinomial here on the left. This again is a times c, so we're going to take our 2 times that negative 12, which is going to give us a negative 24. Now we want to list the factors of negative 24 that are going to add together to give us a 5. Well, those factors are going to be negative 3 times 8 gives us negative 24, and they add together to give us the 5. So we can go ahead and rewrite that middle term. So we have a 2b squared. Instead of a plus 5b, we're going to write that as a plus 8b minus 3b, and then our minus 12 is equal to 0. Now we can factor by grouping. Here we can factor out a 2 and a b. That leaves us with a b plus 4. And in our second grouping, we can factor out a negative 3. And that one leaves us with a b plus 4. These are the same, so we have a b plus 4, and we have a 2b minus 3. All of this is still equal to 0, so now if we have two things multiplied together to equal 0, we set both of them equal to 0. So b plus 4 is equal to 0, or a 2b minus 3 is equal to 0. If you notice this one right here, that is the exact same as what we did over here. So we've already found that excluded value, and that excluded value is b cannot equal negative 4. Now if we look at the other one to solve for b, we have to add 3 to both sides. That's going to give us a 2b is equal to 3. And then to get b by itself, divide both sides by 2. The 2 and the 2 cancel out, leaving us with a b is equal to 3/2. So we know our excluded value, or excluded values in this case, we have more than one, is b cannot equal negative 4, and b cannot equal 3/2. So let's go back and look at our possible solutions that we found. We found that b was equal to negative 4 or 5/6. Well, our excluded value tells us that we need to cross this solution out because that's one of our excluded values. So our final answer to this problem is just the b equals 5/6. Okay, if you remember, again, we were going over the 3 most common methods for solving this. This was our second example, and this, again, was only the first way of solving it. So let's go back and look at our original problem, and let's solve it with the other method. The second method that we used was to make it equal 0 at the very beginning. So in order to do that, we need to subtract this 1 over b plus 4 to both sides of the equation. So on the right, we now have a 1 over a 2b squared plus a 5b minus 12 minus a 4b minus 1 over a 2b squared plus a 5b minus 12 minus a 1 over b plus 4. All of this is equal to 0. Now we need to go ahead and factor so that we can get a common denominator. In order to combine fractions using subtraction, we need a common denominator. So if you remember in the problem we just worked, we already factored this guy. And when we factored him, we got a b plus 4 and a 2b minus 3. So I'm going to go ahead and replace that with the factored form. If this was the first time we were working this problem, we would have to go off to the side and do the a times c method, replace the middle term with the factors, and completely factor it out. But to save time, we have already done that since we're working this problem a second time. And we know that it factors to a b plus 4 times a 2b minus 3. So I'm just going to go ahead and replace that. So now when trying to get a common denominator, we notice this third fraction here, we are missing that 2b minus 3. So that is what we would multiply top and bottom by. So we still have our 1 over the b plus 4, 2b minus 3, minus the 4b minus 1 over the b plus 4, 2b minus 3, and then minus, we have the 1 times the 2b minus 3. So we go ahead and distribute that 1 times. So we are only looking at a 2b minus 3 over our common denominator of b plus 4, 2b minus 3. Now we have a common denominator all the way across, so we can go ahead and combine these under that common denominator, b plus 4, 2b minus 3, and we're going to combine our numerators. We're going to take this guy minus all of this minus all of this. So we have a 1 minus all of the middle one, the 4b minus 1, minus all of that last one, 2b minus 3. Now we can go ahead and distribute that negative sign as if it was a negative 1. So it's essentially a negative 1 that we're going to distribute in both places. That's going to leave us with a 1 minus a 4b plus a 1 minus a 2b and plus a 3 all over b plus 4, 2b minus 3. Now we need to combine like terms. So I have a negative 4b and I have a negative 2b. That's going to combine to give us a negative 6b. Then I have a 1 plus 1, which is 2, plus 3, which is 5. And all of that is over our b plus 4, 2b minus 3. Now we have just one fraction equal to 0. The only way that is the case is if you take the numerator. So we want to take this numerator right here and set it equal to 0. So we have a negative 6b plus 5 is equal to 0, and we want to solve from there. So to get b by itself, we're going to subtract 5 to both sides, leaving us with a negative 6 is equal to -5. Now we want to divide both sides by -6, leaving us with our final answer of a b is equal to a positive 5/6. So we found our possible solution. If we were working this problem the first time, we would then go back and find excluded values, and then discover that 5/6 was not one of the excluded values, making this our final answer. So let's take a look at this problem one more time, and let's use our third option for solving this one. Our third option was to go ahead and, without moving the fractions anywhere, just find your common denominator. And again, since we've already worked this problem out, I'm going to go ahead and replace these denominators with the factored form. So we're looking at a 1 over a b plus 4 times a 2b minus 3. We already factored that before, so I'm not going to show you how to factor it again. If you need to see how we factored that, just back the video back up to option 1, and you can re-watch how we factored that. So now we have a 4b minus 1 over, the factored form of that was the b plus 4, 2b minus 3. Here we have the 1 over b plus 4. We are missing that 2b minus 3, so to get our common denominator, that's what we multiply top and bottom by. So now again we have the 1 over b plus 4, 2b minus 3, minus the 4b minus 1 over b plus 4, 2b minus 3 is equal to, when we distribute that 1, a 2b minus 3 over the b plus 4, 2b minus 3. Okay, so option 3 was, once we had a common denominator everywhere in this entire problem, the only way these fractions would be true, we can just look at our numerators, and we can follow that. So we're going to take the numerators. We have that 1 minus that 4b minus 1 is equal to 2b minus 3. And from here, we can go ahead and distribute that negative sign to get rid of the parentheses. That negative is essentially a -1 that's going to be distributed. So we get a 1 minus a 4b plus 1 is equal to 2b minus 3. Now we want to go ahead and get our b's by themselves, so combine them all together. So let's send that -4b to the other side by adding 4b to both sides. That is going to give us, on the left, we're left with that 1 plus the 1. Let me switch colors again. Go back to the black here. We were left with the 1 plus the 1 because the -4b and the plus 4b canceled out, was equal to, now we have our 2b plus that 4b gives us a 6b minus 3. 1 plus 1 is 2, is equal to 6b minus 3. Now we can subtract 2 from both sides. That's going to give us 0 is equal to 6b minus 5. And now we have to solve for b. So instead of subtracting the 2, it probably would have made more sense to add the 3. Either way is perfectly fine. So if we didn't like this, we could have added 3 to both sides. From here, to get b by itself, let's add 5 to both sides. We took the scenic route on this one, so we get a 5 is equal to a 6b. To get b by itself, go ahead and divide both sides by 6. And you arrive at your final answer of 5/6 is equal to b At this point, again, you would check for excluded values. Since this is now the third time we've worked this problem, we've already checked those excluded values and found that 5/6 is not one of them, so that makes our final answer the 5/6.